What's the lab's mission?
So our mission, we like to say our mission is to create technical options for Sun, which means ideas that are carried to a demo or prototype stage, but stop far short of a product-ready stage. So the option, the notion being that you have to pay to exercise the option, and what you pay is to carry it from where we leave it to where it needs to be a product. So we're not doing products, we're doing technology demos that might lead to products.
And how do you choose what
to work on?
Yes.
Well, so a couple things. First of all, we don't try to cover every area that Sun's into. A lot of the innovation at Sun happens in engineering. For example, Solaris 10 and ZFS and D-Trace and the things that have made Solaris 10 great had nothing to do with the lab. All of that new stuff came out of the Solaris organization.
What sort of the horizon are you looking at
in terms of time? Well, so beyond one product cycle, but not very long. So I tend to say 3 to 5 years. So we don't get involved in the next product in any way, but nor do we try to do blue sky things that are way out. We don't have the manpower to do it, and nor do we have the clarity of vision to figure out what's going to be important. We represent about 2% of Sun's R&D budget, and that's been about the same for quite some time. And we see that as a pretty constant commitment. We have about 150. Most of them are here in California, and some are in Burlington, Massachusetts, and then there's a bunch spread all over. A couple in Australia and one in France.
Is there a lab in those countries?
No, the only labs are here and in Burlington. The others kind of work either out of their houses or sometimes they're in collaborative settings with other universities. There are some teams of what I call one-man band. I don't tend to favor those, as I said, because today to build an effective prototype that's going to do something non-obvious or non-trivial usually requires more than one person. On the other hand, if one person is really passionate about something and has a good idea and can't find anybody else to help, sure. But I would say and then we've on occasion had some very large teams. On occasion up to 30 or so. But those also aren't good because they're not very agile, as you say. So I think generally the teams are 4 to 5 would be a typical size. The ideas, the things that come out of the lab are the ideas that the people in the lab have. And so our biggest, my challenge is to hire good people with good ideas.
Is it difficult today to hire?
I think I wouldn't say it's difficult. We're still doing very well at that. It's still our most important activity, which, as I said, the way we get new ideas is to hire new people, especially people with fresh ideas. And we do okay at that. Yes, we notice Google's there, but I would say that we are not today limited in any way by the quality of the people that we can get.
How do you work with the different engineering division inside of Sun, the Solaris,
right.
The Spark?
Well, there's no set way. Everything is different, and usually it's a matter of personal relationships between the engineers in our lab and the engineers in those organizations. So, for example, I was mentioning that this example of running a soft PBX, running Asterisk on Solaris. So the guy who's in the lab who's working on that is working with Solaris, especially networking engineers, to address some of the Solaris-related problems there. And part of our job as management is to try to make those linkages and then kind of get out of the way because it really needs to be engineer to engineer. The best way to get a project from the lab taken up by engineering is to actually move the people with the project. And sometimes we do that. I don't have a good example recently, but there certainly have been good examples in the past. Probably one good example that I noticed is mentioned in here is Sun Cluster 3.0. That was prototyped in the lab, and the whole team then went over and became the nucleus of the product team. Similarly, Sunray was prototyped in the lab. The engineers went over and became the nucleus of the product team. Another thing that happens that we do try to do is to get people from engineering to come work with us, especially toward the tail end of a project, so that they can learn about it intimately, working with the research team, and then they go back into engineering and become almost the expert for whatever the technology it is that's involved. And that works very well if the engineering team knows long in advance that it's really going to take advantage of something that we've done, and so they're willing to make an investment in getting people involved long before we're done. They've sort of made a decision early, if you will, that they're going to use it, so they can begin to invest people in it. And that's great when it happens, but sometimes engineering doesn't know whether they're going to adopt it until we get further along.
Right.
First of all, we love to get student interns come to work for summers, or for example, we get Australian interns up during our winter because it's their summer. And there's some universities, like University of Waterloo in Canada, that has a co-op program throughout the whole year, and so we get interns coming at a variety of times. So we hire probably as many as 40 interns a year for short stays. So that's one example. We have visiting professors who come often for a year, sometimes staying at their own institution, sometimes actually coming, traveling, and spending a sabbatical year with us, for example. And then finally, we have a thing called collaborative research agreements, where we fund universities to do research on their site with their students and so on. An example at the moment is we have University of Mannheim in Germany. We've got a collaboration going around some of the HPCS networking stuff that was started during the ARPA Phase 2 and is now being continued in part through one of these collaborative agreements.
Okay.
So we do all three of those.